Alrighty everyone, hello and welcome to the sample exam question solutions. So we're looking at question 1, which is the truth table question. This is in both the study event and the mid-sem papers. Alright, so let's get started. So I've copied down the question up here, as you can see, but I haven't labelled what the gates are. So what I think we might do first as a quick revision exercise is just to remember what all our different gates are, is go through the different gates. So our first gate up here, we have an XOR gate. So let's write in what the gate is in here. So we know this is an XOR gate because it's a regular OR gate, which is this little chunk of it here, and it's got this extra little line in front of it. So that's an XOR gate. Here we have an AND gate, which has a flat line and kind of like a D shape, and then here we have a NOT AND gate. Now this is a NOT AND gate, or a NAND gate, because we have a little dot on the output. So a dot on the output means we are negating the gate. Our other gate here is C. So in logic, triangles are sort of a nothing gate, but just don't really do anything. But we have a little dot over here, so it's not of our kind of nothing gate. So this is not C. So we'll call this a NOT gate. There we go. Okay, so we know what our different gates are. Let's get started on our truth table. So I've already started to write out the truth table over here. We've got a column for each of our inputs, A, B, C, and D. And I've also got a couple columns here. We'll populate these in a minute. These are for the two intermediate steps I'm going to use to fill out the truth table, and we have our output over here. So let's write some numbers in here first. So we have 4 bits, and the number of combinations, or the biggest number we can represent in 4 bits, is 16. So let's write all the different combinations of inputs here. This will be like counting up to 16 in binary. So I'll start with A here. 0. So if you read down the list now, you realise we've counted from 0 to 15 in binary. So 0 to 15, that's 16 individual different numbers, and that's also all the combinations of A, B, C, and D. Alright, so what's next? We want to compute the output, and the output is some very complicated logical expression of all the different inputs with a whole bunch of different steps, etc. So what we can do to make things a bit easier is to write out a column with an intermediate, what we'll call an intermediate step in our logic diagram over here. So this column here is going to be the output of this XOR gate up here. Now we can write down the logical expression for the output of this XOR gate pretty easily. So this XOR gate is going to be the XOR of A and not C. So it'll be A XORed with not C. Now I'm sorry if that's a little bit difficult to see on the recording, but that's a circle with a cross through it, which is our XOR symbol. I'll just draw one nice and big up here. Okay, so that's the symbol in the middle down here. That's our XOR. Okay, now I'm not doing an intermediate step for not C because not C is incredibly simple, and I think I can do that all in one go here. So we're going to do A XORed with not C. Now, quick reminder on how XOR works. So we'll do A, B, and A XOR B over here, for example. Wow, that came out very wonky. 1, 1, 1, 0, 1, 0, and 0, 0. So A XOR B, it's exclusively OR. So when the two inputs are different, the output is high, otherwise the output is low. So A XOR B will look something like this. So ideally you'll just be able to remember how this works, or you'll have it on your cheat sheet and be able to refer to it. So let's just nuke all this, and we'll fill out our column. So A XORed with not C. So I kind of have to think as I go through this that all these are the opposite of what they actually are. So we have a 0 and a not 0, which is 1. So we'll have 1, 1, 0, 0, 1 and 1. Cool, okay, that's that intermediate step done. Now, in pink, I'll do another intermediate step here, and we'll do the output of this AND gate next. So the output of this AND gate is going to be the AND of A XOR not C and B. So we'll write up here carefully in brackets A XORed with not C, ANDed with B. It's a bit of a shitty B. Oh boy. I love writing on whiteboards. That's an even worse B. Alright, so what we have here, I'll write it up nice and big, is you've got A, XOR not C, and B. Okay, so quick refresher on AND gates. A, B, A, and B. So the logical symbol for AND is really easy to remember because it looks a bit like an A, and AND starts with A. So A and B. We'll do 1, 1, 1, 0, 0, 0, 1, 0. Okay, cool. That's 1, 0, 0, and 0. So the output is high when both of the inputs, or A and B, are high. Otherwise the output is low. Cool. Okay, so I'll just get rid of this and we'll use that later. So we're going to look we're going to AND this column here because we've already done this operation here. We've already done our A and XOR not C. We put it in this column. So it's this column ANDed with our B column. So this is going to be 0 for the first four. So 0, 0, 0, and 0. And now 1. Right, wonderful. Cool. Now our final step is our output. Now our output is the not AND of A XOR not C and B, which is this wire here, the output of this AND gate, that NANDed with D. So we've already worked out what this wire is going to be, and we've got it in our intermediate step column here. So we need to take the not AND of this column and the D input column. Now let's refresh ourselves on how not AND works. So A not AND B, I'll just put a bar over the top. So it's the opposite of AND. So we can think of this as an AND gate fed into a NOT gate. So we'll have 0, 1, 1, and 1. So the output high is high when A and B are not high. Alright, so let's fill in here. We have the D column and our intermediate step column here. So we're going to have 1, 1, 1, 1.
1, 0. And a whole bunch of zeros here. So a whole bunch of 1 here, 1, 1, 1, 1, 1, 1, 1, and another 1 here, and a 0 here.
There we go. So we've completed our truth table. We have our output column over here and all of our inputs here. Now by using intermediate steps and doing this in a very kind of methodical way, we can make sure that all the operations we're doing in our head are very simple and elementary, and that's how we can avoid mistakes and make it quite easy and step-by-step methodical to get through. If you have any further questions on this, please just email myself or Dave, or post on the Wattle News forum. Thank you.